Assalamualaikum warahmatullahi wabarakatuh. And hi, we are Group 8 from KSF4, Tamhidi Physical Science and Technology. And today we are presenting to you our topic, carbonyl compound. My name is Afifa binti Lutfi, and let me introduce my group members. So this is my group members. The first one is Siti Nur Shakira binti Ahmad Afandi. The second one is Muhammad Syahmi Murshidi bin Shaifuddin. The third one is Rabiatul Adawiyah binti Rizal, and me myself Afifa binti Lutfi. So let's proceed to our questions. Alright, for the task one, so this is the full question for task one. Alright, so we have here compound the U, compound V, W, and X. Alright, so we need to highlight that U will give a positive iodoform test, and also compound X and compound W will also give positive iodoform test. So we need to highlight that because we need to know how to draw the structure. So let's proceed to our first reaction. Alright, so let's proceed to the first reaction between compound U and compound V. So I will explain about this reaction. My name is Afifa and my metric number is 9201101. Alright, so compound Q, it says it will give a positive iodoform test. So we know that iodoform test will give a positive result, which is yellow precipitate of triiodomethane if we have methyl hydroxy group. So what is methyl hydroxy group? Okay, so this is a methyl hydroxy group, and we have a CH3, which is a methyl attached to the carbon, and the OH also attached to the same carbon. So where is the methyl hydroxy group in the compound Q? So we already draw the structure there. So we must put the CH3 at the end of the bond because it will react with the iodoform solution. Okay, so then it will give a positive iodoform test result. Okay, so what is the name of compound Q? Alright, so we can see there it has a benzene ring. Okay, so a benzene ring is attached to the carbon number 2, and there is 4 carbon, CH3, C, CH3. So it's butan, and the OH is attached to the carbon number 3. So the name will be 2-phenyl 3-butanol. And then compound Q will react with heated concentrated sulfuric acid to become compound V. So we can see that OH and H is gone. So we know we must eliminate the H and OH. But how? So here we will use elimination reaction mechanism, which is involve 3 steps. So that we will eliminate OH and H+. Okay, so there is 3 steps in this mechanism. Step 1 is protonation of alcohol. The OH group is not a good leaving group, so it needs to be protonated to form OH2+. So step 1 is protonation. What does it mean by protonation? Protonation is when we react the OH minus from the alcohol, as we can see in the picture below. In the picture there, we have the OH minus from the alcohol group. We react it with the H plus, which come from the H2SO4 in the reagent. So the OH minus will attack the H plus to form the OH2 plus. Okay, so the product we will get OH2 plus, which is still bonded with the alkyl group. So this is the step 1. So for the next step, step 2 is elimination of H2O to form carbocation. Alright, So now we have OH2 plus. So we will eliminate OH2 plus to become the H2O. So the arrow there, as we can see, is from the bond to the oxygen of OH2 plus. Why the arrow is from the bond? Because two electrons in the bond are given to the oxygen OH2 plus. So when the electron is given, the bond between the C and O will be broken. So the OH2 plus will become H2O. And in the product also, we have the carbocation. So the rate of the reaction is low because it is bond breaking process. Alright, step 3. We want to form the double bond between the carbon-carbon. So the name of step 3 is removal of H plus. So we want to form the double bond so that the carbocation will have enough bond to make it 4. So the electron from the, so we can see that electron from the CH bond, okay, C, there is C attached to the H, okay, so the electron from the CH bond there will be given to the carbon-carbon bond, so that double bond will be formed, and the H plus is removed, okay, and the H plus is removed. So where the H plus will go? Okay, the H plus actually will go back to the H2SO4, which is the reagent. Okay, so this is the reaction. This is the reaction that compound V. That then this is the reaction between compound U and heated concentrated sulfuric acid that will become compound V. So let's give the name for compound V. What is the name for compound V? Same like compound U, we have 4 carbon there, CH3, C double bond C, and CH3. And the phenyl, the benzene ring, is attached to the carbon number 2. So the name will be 2-phenyl 2-butene. Alright, so let's move on to the next reaction. Alright, so we're moving on to the next reaction, which is ozonolysis of alkenes. Okay, so this is the compound that we get earlier, compound V, 2-phenyl 2-butene. So 2-phenyl 2-butene will react with the ozone, O3, to form unstable compound, which called molozonides. Okay, so molozonides, which will rearrange spontaneously to form a compound as ozonides. Okay, so ozonides themselves are very unstable compounds and can be easily exploded violently. So due to that, they are not usually isolated but are reduced by a treatment with water in the presence of zinc and acid. So usually we use an acetic acid to give a carbonyl compound, which are aldehydes and ketone. Alright, so when we ozonolysis the compound V, we will get compound X and compound W. So compound X is an ketone, while compound W is an aldehyde. Okay, compound X is a ketone and compound W is an aldehyde. Okay, so what is the name of compound X? Okay, we can see there are 2 carbon, C and attached to the CH3, and there is a benzene ring, is a phenyl attached to the carbon number 1. So the name will be 1-phenyl ethanol because it's a ketone. Alright, so what is the name for compound W? Alright, it is an aldehyde. It's also same, have 2 carbon. So the name will be ethanol. Okay, so let's proceed to the next reaction, which is reduction. So in the questions, it's already said that compound X, this is compound X, will undergo reduction to become 1-phenyl ethanol. Alright, so aldehyde and ketone, we can reduce them to become a primary and secondary alcohol. So aldehyde will be reduced to primary alcohol while ketone will be reduced to secondary alcohol. So the reagent that we can use for the reduction process are hydrogen gas with in the presence of catalyst, nickel or platinum, and heat. Or we can use also sodium tetrahydride and AbH4, or we can use also lithium aluminum hydride LiAiH in ether with H3O plus, or uh, or we can use zinc with H plus and heat. So here we use zinc, H plus and heat. Okay. So so here we have compound X, which is a ketone. So ketone will be reduced to secondary alcohol. Okay. This is a vice versa because if we go to oxidation, primary alcohol will be oxidized to aldehyde while secondary alcohol will be oxidized to ketone. But if you want to reduce that, ketones reduce to secondary alcohol and aldehyde will reduce to primary alcohol. So here we have compound X is a ketone that will reduce to secondary alcohol. Okay, so this is the secondary example of secondary alcohol. Same like the one, same like the one phenyl ethanol. Okay, we have OH and the phenyl there is like the R. The CH3 is like the R prime. Okay, so if oxygen we add if oxidation we add oxygen, but if reduction we add a hydrogen. So I will pass this presentation to next presenter.
Iodoform test can be used as a chemical test for some aldehyde and ketone. The reagents used in this reaction is iodine in sodium hydroxide. As you can see, the structure of compound U is drawn like that because compound U forms an alkene where the OH and H atom is removed to form a double bond. Then it undergoes ozonolysis, breaking the double bond and form compound X and compound W. Each of the compounds when react in iodoform test will show a positive result, that is yellow precipitate of triiodomethane. This is because carbonyl compounds with methyl carbonyl group will show positive result. Ethanol is an aliphatic aldehyde which gives positive result for all tests. But here we use Fehling test because Fehling test is used to differentiate an aliphatic aldehyde from aromatic aldehyde and ketone. It will give positive result for aliphatic aldehyde which brick red precipitate will form. As you can see, compound W, which is an aliphatic aldehyde, shows positive result in Fehling test, that is precipitation of red copper 1 oxide, while compound X, which is an aromatic ketone, shows no reaction in Fehling test, that is blue color solution remained.
Bismillahirrahmanirrahim. So I will continue the question of the class 1. That is refer to the question that is compound X reacts with HCN. The type of mechanism occurs in nucleophilic addition mechanism. So the chemical equation is involved in this reaction is compound X, which is one phenyl. There are two steps of nucleophilic addition mechanism, which is step 1, nucleophilic attack, and step 2, addition of H+. When we want to draw the structures of, there are two steps of nucleophilic addition mechanism, which is step 1, nucleophilic attack, and step 2, addition of H+. When we want to draw the structures of the 1-phenylethanol must be in trigonal planar. These structures allows the attack of nucleophile, which is Cn minus, to occur from the backside. So the C in delta positive, while the oxygen in the 1-phenylethanol is delta negative. Therefore, C is the electrophilic site, so the will attack nucleophilic. I'm sorry. So the C will attack nucleophile, which is Cn minus, or if we refer to the arrow, the Cn minus is attacked by the carbon of 1-phenylethanol electrophilic site. The bond C and O will break heterotically. So the arrow in the double-headed curve arrow. So in this step, we want to break the bond. Therefore, the rate of reaction should be slow. So the Cn minus is added by C and the O become O minus because it's gained electron from the double bond just now. Okay, for the step 2, the O minus is unstable, so that we have to add the other electrophile, which is H plus to the O minus. O minus become nucleophilic site now, so the O minus is attacked by H plus, which is the electrophile. So O is attached to the H. There we will see in the product that the both nucleophile and the H is added to the carbonyl group. In this,
We have choose garlic as our chosen plant. The functional group presented is carbonyl compound. Garlic is actually mentioned in Surah Al-Baqarah, ayah 61. And the meaning of the ayah is, and recall when you said, O Moses, we can never end the one kind of word. So call upon your Lord to bring forth for us from the earth its green herbs and its cucumbers and its garlic and its lentils and its onion. The carbonyl compound were found in black garlic. Black garlic is actually a type of aged garlic that is deeply colored brown. The result of the color is due to the Maillard reaction or caramelization, and it's actually not a fermentation reaction. It was first used as a food ingredient in Asian cuisine. One of carbonyl compound in black garlic is 1-hydroxy-2-butanol. The structure was shown below. Okay, so the aroma compound profile of fresh garlic was actually relatively simple, with many sulfur-containing compounds and few aldehydes and ketones. There were 20 volatile compounds were identified and classified into 8 groups, derived from S-alkenyl 1-cysteine, other sulfur-containing compounds, alcohols, aldehydes, furans, acid, ketones, and other compounds. 52 aroma-active compounds were found in black garlic, which could be classified into 7 groups, including alcohol, aldehydes, ketones, sulfur-containing compound, heterocyclic compound, organic acid, and other compounds. There were 24 aroma-active compounds with log flavor dilution base 2 bigger and equal than 2, including 8 sulfur-containing compounds, 6 heterocyclic compounds, 2 carbonyl compounds, 2 alcoholic compounds, 3 acids, and 3 unknown aroma compounds. There were 2 carbonyl compounds, and one of them are 1-hydroxy-2-butanol, which is savory, which were not actually detected in fresh garlic.
This compound, which is 1-hydroxytobutanon, it's helped to give a pleasant flavor, which are sweet and sour when we eat it. Okay, so some people might didn't know the Maillard reaction is actually a chemical reaction between amino acid and reducing sugar that give brown food its distinctive color. So from the white color of raw garlic, we have a brown color of black garlic. So what is the benefit of this plant? Since we frequently saw raw garlic only. So black garlic has higher antioxidant levels may help to prevent complications related to diabetes and can help to fight against cancer such as growth of colon cancer cells. It also helps lower of cholesterol and triglyceride, which in turn reduce your risk of heart disease.
So that's all from us. Thank you. I hope you enjoy this presentation.